For these problems, we're going to graph the function by first putting it in what our book calls standard form, and we're going to do that by completing the square. So we're going to start with y equals x squared minus 8x plus 5. So we're going to do something a little bit different than what we've done in the past, in that here we're not going to set it equal to 0 like we did when we were solving by completing the square. We're going to keep y as it is, and we're going to put the 5 on the other side. So y minus 5 is equal to x squared minus 8x. The rest is pretty similar to what we've done before. We take the b. First of all, we ask ourselves, is a 1? Yes, it is. So we're good there. We take the b, which is negative 8, divided by 2. So that's negative 4. And we square it. So we get 16. We add 16 to both sides. So this is now a perfect square trinomial that gets factored into x minus 4 quantity squared. Remember, that's either half of b or the square root of this number. That's equal to y plus 11. Okay, that's just negative 5 plus 16. So now we're going to put it in the form that we are more used to, in the form that they have given us here. So we subtract 11 from both sides. So now we have it in standard form, where h comma k, which is our vertex, is the opposite of this number. So that's 4 comma negative 11. And in this case, because a is positive, this number is positive, this is going to be a minimum. So we would go to 4, negative 11, and we would do our graph, the regular graph of y equals x squared from there. So we go 1 to the right and 1 up, 2 to the right and 4 up, 1, 2, 3, 4, and you can use the axis of symmetry, which in this case would be x equals 4. Now remember, once again, we're just doing a rough sketch. Let's do number 28. So we have y equals negative 1/2 x squared plus 6x minus 16. So here, our a is not 1. But what we're going to do, unlike what we've done in the past when we were solving by completing the square, in the past we would just divide everything by a. We are not going to do that in this case. What we're going to do is we're going to factor this a out of the first two terms, out of these two terms. Before we get started with that though, let's put this c on the other side. So we have y plus 16 equals, and we're going to factor out that negative 1/2. So this will be x squared. And when you factor out the negative 1/2, you're going to divide 6 by negative 1/2. So this will be negative, and it'll be, here, let's show you over here, 6 divided by negative 1/2. Dividing by negative 1/2 is the same as multiplying by the reciprocal, so negative 2 over 1. So this will be negative 12. To double check your work, you distribute this and make sure we do get what we started off with. Negative times negative is positive, and 12 times 1/2 is 6. Okay. Now we're going to complete the square. Oh, there's an x in here too. Okay, so we're going to take the negative 12, that's our b, divided by 2. That's going to be negative 6. And we're going to square negative 6. So that's 36. So we're going to add 36 here. Now here's what the tricky part. Normally, you would think that you're going to add 36 to both sides. But let's take a look and see what we really added here. Did we really add 36? Well, let's take a look. This negative 1/2 has to be distributed to this parentheses. Negative 1/2 times 36 is really negative 18. So we really added negative 18 to the right side. So we have to add negative 18 to the left side as well. So be careful when adding things where there's a parentheses and a distribution. Don't just automatically say, oh, add 36 to both sides, because that's not what we really added here. Combine these two terms, you get y minus 2. This is negative 1/2. We're going to factor this perfect square trinomial. It's x minus 6. That's half of our b, or the square root of this. And it's negative because of this squared. Now all we have to do is just put it in standard form by adding 2 to both sides. This is a little bit tedious, but it's not beyond you. You can do this. Okay, so now we have it in this form. Our h is 6, k is 2. That's our vertex, 6, 2. And in this case, it's a maximum because our a is negative, so there's going to be a reflection over the x-axis. It's going to be an upside down parabola. So you go to 6, 2, and there is a vertical shrink by 1/2. So instead of going 1, 1, you're going to do 1/2. Instead of 2, 4, you're going to go 2, 2. But remember, you're doing everything upside down because of the negative. Okay, let's use our symmetry. So once again, we're just doing a rough sketch. This is what the graph would look like, something like this. Let's do number 29. We're completing the square. So y, and I'm going to subtract the 3 right now to save some time and factor out the negative 2. Note that we would factor this out even if the 2 did not go into both of these. You just need to factor it out of both of them. And if it didn't go into it, you would just have a fraction left, which is no problem. For example, if this 4, instead of being a 4, was a 3, and in here, instead of having a 2, we would have 3 over 2. Okay, so we're going to take our b, which is 2, divided by 2, we get 1. And we're going to square 1, so that's 1. We're going to add that to one side. And let's see what we really added to this side is the negative 2 times 1. That's negative 2. So we really added a negative 2 to our right side. So we got to add a negative 2 to our left side as well. So here we get y minus 5. let's factor this perfect square trinomial. So we get x plus 1. It's half of our b, or the square root of this number. Now we just have to add this to the other side, so we have it in standard form. So it becomes plus 5. So this is now in standard form, and the vertex is at -1, 5. It's the opposite of this, comma, this number. So you go to -1, 5. It is also, again, reflected over the x-axis because of this negative, and there's a vertical stretch by a factor of 2 because of this number, the a. So instead of going 1, 1, we're going to go 1, 2, but upside down. There's another symmetrical one right here, because this is our axis of symmetry. And instead of going 2, 4, we're going to go 2a, but going down. So 2, and then 2, 4, 6, 8. Let's put another one over here. So this is a thin, or what we say vertically stretched parabola, and it's upside down.